Good morning, everybody.
Good morning.
Today is Tuesday, May 5th, and our goal is that we can write the equation of a circle given the center and the radius, and graph circles as well. So we've now started a new unit. This is actually Unit 10, and we're going to give it a shot here.
This is our last unit of the year, right, Mrs. Talhami?
Not quite. We actually still have, it's close to the last unit. We have 2-dimensional and 3-dimensional, but those are things that we've seen in prior years, like area and perimeter and volume. So this is the last, brand new topic they're going to be seeing. All right. So to start off, we want to look at the equation of a circle. Now, I want you to think back to when we did constructions, and I asked you to draw a circle using your geo tool. So in order to draw a circle, think about it. I needed to give you a point at which you had to start your geo tool or your compass, and then you had to know how far out did you want me to go to, Ms. Talhami. So we needed to know how far out to go to make the circle. I know that's not a great circle, but there you go. All right, so 2 things that are very important for you to graph a circle are the center and the radius. So I'm going to write that on the side here, that the center and the radius are the 2 things that you need to write the equation of a circle or to graph a circle. So now if you look at this circle that I've been given here, there's no particular coordinates. It's just giving you a center and a circle. Now if I choose any point on this circle and make the radius, I can complete this by making a right triangle. So if you notice, it's all from the center. This part of the right triangle would represent the distance of the x coordinate from the center, and this part would represent the distance of the y coordinate from the center, and this part right here would represent the radius. Now I could do that with any point on the circle, so I'm going to change the color and give you another example just so that you could see it. Here's another point where I can make a right triangle from any point of the from any point on the circle, and notice the radius will always be the same going all the way around the circle. So now when we have a right triangle, we can always use, if I'm talking about the lengths of the sides, we can always use the Pythagorean Theorem. Now if you remember the Pythagorean Theorem, some of you remember it like this. Some of you remember it like this. So now I'm going to make it relate to the circle here. So if I take a look, using this right here, I'm going to make one leg the distance or the difference between the x value. So it's going to look similar to the distance formula. So I'm going to have x minus, now just give me a second to explain what this h is. And then for the other leg here, I'm going to do y minus k, and I'll explain what that h and k are in just a minute. And then my hypotenuse in this picture is the radius. So this is a very important formula right here. If anything, this is what you want to copy down, because the only parts of this formula that you are going to replace are the h, the k, and the radius, where the h and the k represent the center of the circle. So that's the coordinates for the center of the circle, and r is the radius. So a couple things important here to realize. It's going to be x minus whatever value the x coordinate of the center is, and y minus the k value, which y value of the center of the circle, and then it's going to equal the radius squared. So if you look at this first example, which we'll go through some more of these examples, it's not written as radius squared. So you might have to ask yourself, what number squared would give me 81? Because that would represent your radius. X minus my x value. So that means here 7 is my x value. But it's not as simple for this second question right here. Why, hold on a minute, it's not minus here. So we have to think about what happened. In order for it to turn plus, if you remember, and I'll just briefly do this first one here, y minus what value would turn this to plus? Some of you are saying, hold on, Miss Murphy always says minus a negative would make it positive. So actually, your y value here is a negative. And then, like we said before, what number squared would give me 81? And some of you are saying, hey, Mr. Talhami, 9 squared is 81. So do you think you can pull the center and radius from this first example? Do you think you can?
I was just going to say, well, let's give it a try. So we're going to keep the sign of the number. So the center will be -7, -10, Mrs. Talhami?
That's the trick, and that's exactly what I wanted us to think. It's x minus whatever the x value is here. So it's x minus 7. You actually take the opposite value.
Okay, so we're not looking at that minus sign. We're only looking at that number.
Right.
So the center would be, oh, excuse me, 7, comma, -10.
Exactly.
And the radius is 9.
Right. So now look at what Miss Murphy said. It's very important. If this piece, rewriting it here, confused you, then think about this. Here, I'm going to erase it for a quick second. Let's erase all of this. See if it goes away. Oh, nice. It didn't erase. Sometimes that happens. So here's what you could think about. Look at this value. Do the opposite sign. Instead of a -7, it's a +7. Instead of a +10, it's a -10. So that's probably your fastest way to get the center, which is what Miss Murphy just did.
Yes.
And then to get the radius, you must ask yourself, okay, well here, what number squared? So r squared has to equal 81. What does that mean r equals? So here's the math. R would have to equal the square root of 81, which is 9. So it's important that you guys understood that math because it's not always going to be a perfect square here. So you need to consider that.
So we take the square root at all times.
Yep, if it's not already written as a number squared, you take the square root. Absolutely.
Okay, so let's try number 2. So for the center, we're going to take the opposite of +5, which is -5. Opposite of +1, which is -1. And the square root of 25, which is 5.
Beautiful. So your center is -5, -1, and the radius is 5.
That's easy, Mrs. Talhami.
Great. So if you guys want to pause the video and try the rest of these, and then press play when you're done, go for it.
Okay, so opposite of -4, +4. Opposite of +5, -5. And the square root, my picture is over it. What is that number? 9 is 3. It's nice when the numbers work out evenly. Unlike number 4, -9, +5. But here, I don't know of any number times itself in my head that would give me a 12. So can we just leave it as the square root of 12, or do we always simplify?
Square root of 12 is fine. You can simplify it if asked, but this did not ask for us to simplify.
So we have to just leave it like that.
You could. If you simplify, you won't lose points unless you do it incorrectly.
Okay. So center, +1, +5. Square root of 16 is 4. 4 times 4 is 16.
All right.
-5, -6. And we already know the square root of 9 is 3.
Beautiful. That was pretty easy, Miss Murphy.
I agree.
All right. So now let's change it up a little bit. If you take a look here, in this picture, it actually already graphed the circles for you. We have to determine what is the center and what is the radius so that we can properly write the equation. So I'm not sure if you could see this. I'm going to zoom in a little bit more. So if you look at circle A, Miss Murphy, can you tell on your end what the center is there?
This is really strange, Mrs. Talhami, but the whole thing just disappeared from my screen.
Oh.
The whole lesson popped away and said something needed updating.
Oh, yeah. You can click skip this version.
I didn't click anything. Oh, I'll just go back onto Zoom.
Yes, yeah. So you probably got a software update. I got it on my laptop too. It was for JavaScript, I believe.
Well, this is really strange. It's just gone.
Can you click back into Zoom?
Nope.
Can you do skip this version for the update?
It just disappeared without me even responding to it.
Oh, interesting. Okay.
Oh.
All right. Well, so then let's test your listening skills.
Excellent.
Great. All right. So then I'll tell you for number 7, if you want to find the center, because it's graphed for us, it looks like I have to go back to -7 and up to +6. So the center for this circle is -7, +6. And the radius, in order to determine the radius, the easiest way is to draw yourself a line from the center, either to the right, left, up, or down. Because if I draw it diagonally, I don't know what that distance is. So the radius here is, it looks like it's 2. So with a center of -7, 6 and a radius of 2, do you think you could write the equation?
Are you asking that to me, Mrs. Talhami? Repeat that?
Sure.
The center is, I was trying to get back in.
That's okay. The center is -7, 6, and the radius is 2.
Okay, so I would start, I call it like making a skeleton of the equation.
Sure. Okay.
I would draw 2 sets of parentheses with a plus sign between them and little squares on the outside. And then I would put my X in the first parenthesis and my Y in the second.
Okay.
And I know that the center has to be the opposite. So the opposite of -7 is +7 in the first parenthesis.
Beautiful.
Opposite of +6 is -6 in the second parenthesis.
Wonderful.
And I have to go backwards of taking the square root, which is to square. So 2 squared is 4.
Beautiful. Very nice job, Miss Murphy.
Thank you, Mrs. Talhami. You're a good teacher.
Thanks. So here, let's look at this next circle. The center is a +4, +2, and the radius is 1, 2, 3, 4. Okay. So with the center of 4, 2, and a radius of 4. Let's do that skeleton that Miss Murphy was talking about. That's a wonderful idea. Put the x in the first parentheses, y in the second parentheses, and then...
And we just go and fill it in.
Go for it.
Opposite of positive 4 is negative 4. Opposite of positive 2 is negative 2. And we square the 4. 4 squared is 16.
Beautiful. Wonderful. This is a piece of cake. Or maybe I should say a piece of pie.
That's cute. Pie. Apple pies are too. Cherry pie, delicious.
Right, and then we have 2 more we could get done very quickly. So here for this A circle, so I'm doing A first, then I'll do B. But looking at
this would be a good place for students to pause, look ahead, try to do the questions on their own, and then restart the video and check their answers.
That's a great idea.
Okay, so the center of the first circle
is 6, negative 3.
Radius
is 3.
So we have parentheses x minus 6 squared plus y plus 3 squared equals 9.
Beautiful. And then the center of B is 2, 1. And the radius is 1, 2, 3, 4, 5.
1, 2, 3, 4, 5.
Everybody in the car.
X minus 2 squared minus 1 squared equals 25.
Oh, lovely. Wonderful job. Okay, and one more set of questions, Miss Murphy.
Okay.
So we've been able now to take the center and the radius out of an equation. We've been able to take the graph and write the equation. And then our last task here is to be able to take the equation and graph the circle. Okay, so let's do this first example here. The equation says x minus 3 squared plus y plus 2 squared equals 4. And our task is to graph that. So what do you think is the first thing we should do before we even graph it?
I would pull out the center, which would be positive 3, negative 2.
Wonderful.
Take the square root of 4, which is 2.
So
and I would graph that and label that circle A.
Beautiful. So our center is 3, negative 2. So let's go to 3 and negative 2, and I'm going to label that A. Now, how do you think I can go a radius of 2 all the way around? What do you think? I wonder if they were listening before. What's the easiest way to get the radius?
Hopefully they're thinking north, south, west, east.
Beautiful, and that's exactly what it is. So I'm going to go north, which is up 2. Then I'm going to go south, left 2, to the left. I'm sorry, down, to the left, and to the right. So the 4 directions, left, right, up, and down, with a radius of 2. And then to the best of my ability, I'm going to make this like a round circle. Oh, and thankfully I have the iPad, so it actually perfects it.
That's nice. And then we could do the different color for circle B.
Absolutely.
So each one of these, we're just pulling out the center and the radius. So for B, the center is negative 6, positive 7. Square root of 9 is 3. So our center is 3.
Radius, you mean, is 3.
Oh, radius is 3.
Yeah. So I'm going to go to negative 6, positive 7. That's my center. I'm going to name it B. And then I'm going to go a radius of 3 to the right, above, to to the left and below. To the best of my ability, I'm going to round it out. It's very important that you do to the best of your ability the roundness, because if you don't, it'll look like a square, like sideways, slanted, or like a diamond. So you need to round those
Arcs. You can make like 4 little arcs.
Exactly.
Yeah. I'm looking ahead to number 2, Mrs. Talhami, and I'm glad that we're going to cover this one because for the first time on this worksheet, we're seeing x squared all alone.
Oh, no.
Which means that there's nothing next to it.
So if I wanted to write it like this, what value would be inside with the x?
A 0.
Oh, so this is almost like saying x minus 0 squared because nothing is with it. Right?
That's right.
Wonderful. So I think
So
we can still
0,
apply that.
positive 7 is our center. And our radius is the square root of 25, which is 5.
Beautiful.
And we can just quickly graph that so we don't take up too much of their time.
Good. So we have to go, this is A, and I have to go 5 down. I have to go 5. Uh-oh. Looks like I didn't make the graph long enough.
We could just sketch.
Oh, mine's not as round. Let's see. I'm going to try that again. Even the iPad didn't understand what that shape was. All right, and we're ready for this last one here.
So we have a center of 4, negative 5, and a radius of 3.
So let's go to 4, negative 5, and label that B, and do a radius of 3. Wonderful. And there you have it. That is how you graph circles. So if you have any questions, feel free to message myself or Miss Murphy, and have a great day.
Bye, everyone.